Hi, my name is Tobias Moser. I'm a clinician scientist at the Göttingen Campus. My team and I aim to discover how hearing works and how it fails in hearing impairment. To combat hearing impairment, we're developing new therapies that promise to transform hearing restoration. I grew up in East Germany. The wall falling paved my way into science. So let me take you into a journey into our sense of hearing. In the cochlea, sensory hair cells and spiral ganglions pick up the sound and inform the brain. The cochlea spirals from the high-frequency base to the low-frequency apex. When our hair cells don't work or are lost, we lose our sense of hearing. Yet when the neurons remain, we can electrically stimulate them to restore some hearing. When we stimulate the base of the cochlea, we perceive a high-pitched sound. When we stimulate the apex of the cochlea, we perceive a low-pitched sound. Yet the hearing with an electrical cochlear implant is far from normal. I brought you a simple simulation of electrical hearing of a piece of music. This is so poor because the current spreads far and activates neurons that represent very many different frequencies. This is a bit like playing piano with a fist instead of the fingers, and it represents a wall that seemed impossible to break. We broke this wall by using light instead of current, because light can be confined in space. To make the neurons of the cochlea light sensitive, we use harmless viral vectors to bring in light switches. Next, we implant an optical cochlear implant that transforms sound into a pattern of light from up to 64 emitters. In addition, we develop gene therapy to replace defective genes in select forms of genetic deafness. Much remains to be done before gene therapy and optical cochlear implants will be available for the hearing impaired. Challenges include safe and stable gene transfer. We hope that gene therapy will abolish the need for hearing aids or cochlear implants in select forms of genetic deafness. We expect that the optical cochlear implant will restore near natural hearing. We strive to make these new therapies available within this decade.